Hello everyone, I am Yuchen Han. In this video, I will be presenting the methods that are used to answer the query in Assignment 2. Let's start with the first program, which performs a sequential scan search on the data points. In this program, it first reads each data point and the query from the input file. Then it checks the coordinates of the data points and compares them with the coordinates of the query coordinates. So if the x coordinate and y coordinates of the data points falls within the x and y range of the query respectively, then the result variable will be incremented by 1. And after scanning all the data points, the results which represents the number of points covered by each query will be written into this output file. And the total query processing time and the average time for each query will also be written into this file. So we can check the output by running this file. Then we can check the output here. So each line represents the number of data points covered by each query. Then we can see the total processing time is around 4.5 seconds, and the average time is around 0.02 seconds. So this is the performance for the sequential scan search. Next, I'm going to present the second method, which performs array search on the data points. This program consists of two classes, node class and array class. And first, for the node class, it consists methods such as checking if the node is a root node or leaf node. It also responsible for checking if the node occurs an overflow issue or not. And for the array class, it contains the method for inserting node handling overflow. I set the parameter b as 4 in this program, which means that each node should contain 2 or 4 child node or data points. So the algorithm needs to handle overflow if the child node or points of a node exceeds the upper bound 4. Instead of iterating through all data points, array search is more efficiently search for data points within a given query. So the array-based search begins by checking if the boundary rectangle of a particular node intersects with the given query, and if there's an intersection, the algorithm continues to perform a deeper search within the child nodes or the data points of the node. The algorithm only traverses the node if it intersects the query, so this approach can significantly improve efficiency by reducing the number of comparisons required and pruning large portions of data points if then they don't have intersections with the query. So then we can run this program and check the performance with the sequential scan output. I'm just going to pause the video for a second because it's gonna take a while to build the array. Then we can check the output of the array search. So all the result has been written into this file. Then we can compare it with the sequential scan. So the average time for each query is about 0.0002 seconds, and for sequential scan is about 0.02. So which means that the average time for each query in array is about over 100 times faster than sequential scan. So the using array in searching the data points is more efficient. Next, I will move on to the third method, which applies the divide and conquer technique in array-based search. This program is quite similar to the archery-based search. All the functions in archery class and the node class are the same. And the only difference is in this program, instead of constructing one archery and traverse using constructing one archery using the entire data set and traverse through the whole archery while answering the query. This program calculates a divided line and which can evenly divide the data sets into two hops along the x dimension. And then we can build two archeries using the points from the left side of the building the archery from the left side of the data points and the right side of the data points. For each query in the query list, we compare the x coordinate of the query within the divided line with the divided line. If the x coordinate is smaller than the divided line, and indicates it is at the right side of the divided line. So this means that it only has chance to cover the point from the left tree. So query will only search the left tree. If the query is at the right side, then it will only search the right side tree. If the query crosses the divided line, the else condition, then it could contain points from both right and left archery. So the algorithm divides this type of query into two parts, and the left part searches the archery, the left archery, and the right part only searches the right archery. Then they combine the number of points together and then append to the results list. Then we can run this program. Then I first clear it. I'm going to pause the video for a second until they pop up the result. Now we can check the output. I have written the output the result into the divide and conquer output file. You can see that the average time for each query in divide and conquer file is about 0.0016 seconds, and then we compare it with the archery method. The average time for each query is about 0.002. So we can see that there is a little bit more faster when we apply divide and conquer technique into the archery output. It's about over 1 time faster than using the archery search. Thank you for listening.